Hello everybody and welcome back to e-learning day number 5. Can you guys please flip to page number 15 in your notes packet? Today we are going to continue on to target 8D, which will be our last target of KC number 8. And today what we're going to be doing is we're actually not going to be using our graphing calculators today, and we're going to be finding both our vertical and our horizontal asymptotes without using our calculators. All right, and we're also going to talk about another definition, which is this holes and how there might be holes in one of our graphs. All right, so vocabulary for today is points of discontinuity, and that's where the graph does not connect. All right, so that might look something like, if we have our graph here, we might be approaching this asymptote, but we might have a hole in our graph right there, and that would be a point of discontinuity. All right, and then we have our vertical asymptotes, which again are just the vertical lines that correspond to the zeros of the denominator, and we're going to talk about that today. Let's go ahead and jump right into example number 1. So the first example, we are going to be looking for horizontal asymptotes. All right, and here's how we're going to do it. You really only have to look at the degree of the numerator and then the degree of the denominator. All right, so if the degree of the numerator is equal to the degree of the denominator, then your horizontal asymptote is just going to be your leading coefficients of both. All right, if the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is y is equal to 0. And if the degree of the numerator is greater than the denominator, then there's no horizontal asymptote. So let's look at a couple examples. Letter A. All right, the degree of my numerator here, so you have to look at x, which in this case we don't even have an x, right? So in this case, my degree of the numerator would be a degree 0. And the degree of the denominator, see how this is x to the second power? Well, that's the highest degree. So I'd say that's degree 2. Okay, so now we say, well, the degree of the numerator is less than the degree of the denominator. Therefore, we have a horizontal asymptote at y is equal to 0. All right, on to example B. B, on the top, we have x, which is really x to the first power. So I would say the numerator has degree 1. The denominator also has degree 1. Okay, so this would be when they're equal to one another. So we just take those leading coefficients. Okay, so this leading coefficient is a 1x, and that is a 1x. So I'd say, okay, well, we have 1 over 1 for horizontal asymptote at y is equal to 1. On to letter C. Letter C. We have my numerator x to the third power, so I'm going to say degree 3 over my denominator is degree x to the second power. So now we have where our numerator is greater than our denominator, which is this third case here, which means we have no horizontal asymptote. So for this one, I'm just going to say no horizontal asymptote. All right, and letter D, the degree of our numerator would be x to the second power. So that would be degree 2 over degree of the denominator. This one's also to the second power, degree 2. So remember, when they're equal, we take the leading coefficients of both. So in this case, my leading coefficient of this x squared is just 1, and then my leading coefficient of this x squared is a negative 4. So I would have 1 over negative 4, or you could say a horizontal asymptote at negative 1/4. All right, and now we can go ahead and check all these by actually graphing them. All right, so if we look at a graph of this first one, okay, letter A over here, you can see that we have a horizontal asymptote right here at y is equal to 0. So we know that that y equals 0 is correct. In letter B, we have a horizontal asymptote at y is equal to 1. So we know that that one is also correct. In letter C, we said no horizontal asymptote. So we can see that if you were to try to draw a horizontal asymptote, you can't make it so that it doesn't go through one of your graphs, right? So in this case, there is no horizontal asymptote, which is exactly what we got for letter C. And in letter D, we found a negative 1/4. So it's a little bit harder to see, but it should be right here at this negative 1/4 for letter D, which is exactly what we got here. All right, so example 1 is all about finding those horizontal asymptotes, but if you flip the page over, now we're going to start looking at our vertical asymptotes. All right, and to find any vertical asymptote, we're going to follow a couple of steps. The first step is to factor both the numerator and the denominator. Then we're going to set any common factors between the numerator and denominator equal to 0. And then we're going to solve x to find any wholes. And then we'll set any remaining factors in the denominator equal to 0 to find our vertical asymptotes. So what does this look like? Let's look at example letter A here. All right, our numerator is 4, so we really can't factor that at all. However, our denominator is x squared minus 3x. So we could take an x out of both of these. So if we were going to factor this, we'll leave this 4 over, now I'm going to factor out an x. So x times x is x squared minus 3, because x times 3 would be that negative 3x there. All right, and now what we can do to find any vertical asymptotes is we can just take that denominator and set it equal to 0. So that means I have to take both of these and set these equal to 0. So I'll take this x first, set it equal to 0. I get x is equal to 0. Then I will take this x minus 3 equal to 0. So I have to add 3 to both sides. And I get x is equal to 3. And both of these would be my vertical asymptotes. So I'd have vertical asymptotes at x is equal to 0 and x is equal to 3. And that's all there is to it for that one. Okay, this one doesn't have any wholes. We'll discuss wholes in our next example, letter B. All right, on to our next example. Okay, step 1 is factor both the numerator and the denominator. So the numerator here is x squared minus 9. All right, so I have a term that's squared, I have subtraction, and there's only 2 terms. So in my head, I should be thinking, oh, well, this one's a difference of squares. All right, so I can then say, all right, square root of x squared is x times x. Square root of 9 is 3. And remember, we have to cancel out that middle term. So I'm going to make one addition and one subtraction. Now we go on to factor the denominator, which in this case, I first check for a GCF to see if I can pull anything out of all 3 of these terms. And all 3 of these can be divided by 3. So 3 divided by 3 just gives me x squared. Negative 6 divided by 3 leaves me with a negative 2x. And last, negative 9 divided by 3 is negative 3. Okay, now we can go ahead and factor this here. All right, remember we have our x. We want to multiply to our last times our first term, which is 1. So negative 3 times 1 is negative 3. Add to a negative 2. All right, so our factors should be a positive 3, or negative 3 rather, and a positive 1. So we have x minus 3, x plus 1. But don't forget, we have to multiply it because we divided it by 3. We have to multiply this by 3. So I have 3, x minus 3, x plus 1. Now this is where our wholes come into play. All right, when we have common factors, remember how we talked about, okay, well, this x minus 3 cancels out this x minus 3. If you ever cross anything out, we have to take that and set it equal to 0. So you'd have an x minus 3 is equal to 0. So add 3 to both sides. We get x is equal to 3, and this is our whole. So we have a whole at x is equal to 3. All right, but now to find our vertical asymptote, like we did in letter A, we have to take our denominator and set it equal to 0. So in this case, our denominator is now 3 times x plus 1. We set that equal to 0. So that 3 almost just kind of disappears because we can divide each side by 3, which cancels this out. But 0 divided by 3 is really just 0. So now we subtract 1 from both sides, and I get x is equal to negative 1. So then I have a vertical asymptote at x equals negative 1. So that's how it would look with a whole in your problem as well. On to example C. In this one, our numerator is just x plus 2, so you can't really factor that at all. And in the denominator, we have 2x plus 6. So really the only thing that I can think to do with that denominator is divide both of those terms by 2. So then I have x plus 2 over, we're going to factor out a GCF of 2. So then this just becomes x plus 3. All right, we can't cancel anything in the numerator and denominator out. So there aren't any wholes in this one. So we'll just take our denominator, set it equal to 0 to find our vertical asymptotes. So I have 2 times x plus 3 is equal to 0. We can divide each side by 2 so that these cancel. So x plus 3 is equal to 0. Subtract 3 from both sides. I get x is equal to negative 3. So this one has a vertical asymptote at x is equal to negative 3. All right, and that's really it for example letter C. So now we'll take a look at our last example for today, and that is letter D. Okay, when I look at the numerator here, I first always look to see if there's anything that I can factor out of all 3 of these. And all 3 of these are divisible by 2. So I'm going to divide each of them by 2. So 2 divided by 2 is just 1, or we could just write x squared. 10 divided by 2 is 5, so I have 5x. And 12 divided by 2 is 6. Okay, I still do want to factor this in parentheses. So we multiply to the first, which is 1, times the last, which is 6. So we get 6. Add to the middle, which is 5. Okay, now lots of people think, okay, 6 times 1, but we actually want to do 3 times 2. So I would have 2 times x plus 3, x plus 2 as my numerator all factored out. Then I have to do my denominator. Denominator, we're going to have to factor this. So again, I want to multiply to my first, which is 1 times 2. So we're multiplying to 2. We're adding to the middle, which is 3. So 2 times 1 multiplies to 2, adds to 3. So as my denominator, I would have x plus 2, and then x plus 1. Look for any wholes. Remember, wholes are if I can cancel anything out. So see how this x plus 2 cancels out this x plus 2? So let's set that x plus 2 equal to 0. Subtract 2 from both sides. I get x is equal to -2. And this is a hole in my graph. All right, so again, that's just that point of discontinuity. All right, so if we were looking at our graph, okay, at x is equal to -2, which is right here, it might look something like this, where it just had a hole at that point. All right. Then we can take my remaining denominator here, x plus 1, and we can set that equal to 0. So I'm going to say, okay, x plus 1 is equal to 0, and this will find my vertical asymptote. Subtract 1 from both sides. X is equal to -1. So then we have a vertical asymptote at x is equal to -1. And that's going to be it for letter D. So now today we just discussed how we can find both horizontal, vertical asymptotes, but also holes in a graph without actually graphing them on our graphing calculator. All right, so your assignment for today is another Delta Math assignment. All right, this one is a little bit longer. I had you do 5 problems where you're finding the horizontal asymptote and 5 problems where you're finding the vertical asymptote. All right, but it's going to look exactly the same as our examples for today. So you can go ahead and log on to Delta Math, and once you complete your Delta Math assignment, that's going to be it for day number 5 of e-learning. All right, have a great rest of your day.